Hello guys, welcome to Java session. Today's topic is object lifetime. In today's session, we will discuss about garbage collection, object finalization, initializers, field expression initializers, static initializers, instance initializers. Garbage collection. Garbage collection is nothing but managing memory efficiently. So this efficient memory management is essential in runtime system. If we don't manage memory efficiently, then application will go down. So in order to application be up, make up and running, we need to maintain this heap memory well. So for that, it would require this garbage collection to be maintained well. So storage objects is allocated in designated part of the memory called heap. So generally whatever the objects we create, those will be allocated in the heap memory, and which has finite size. This garbage collection is a process of managing heap efficiently, that is reclaiming memory occupied by the objects that are no longer needed and making it available for new objects. Suppose if we have one test program, okay, in test class we have some variables, okay, a integer a b c, and if you are not using any of these variables and the calling program, uh, if you are calling this test application from a different standalone application, and some of these programs, I mean like some of these variables are not being used, then this garbage collection, what it does, it will clear that memory and it can be used for other objects. So Java provides this garbage collection and it maintains this heap efficiently. And see, it meaning a runtime environment can take care of memory management without program having the special take. We need to take a special action. I mean, like as a programmer, we need not to write any special program to maintain this memory. So Java itself, it clears out the unused memory and it can be used for other objects. So an automatic garbage collector essentially performs two tasks: decides if and when memory needs to be reclaimed, and find objects that are no longer needed by the program and reclaims their storage. So Java provides thread-based multitasking, meaning that they can have several threads executed in the JVM, each doing its own task. So what it does, it will check whether any particular object is reachable or not reachable. If any of these objects are not reachable, what it does, the garbage collector will clear that memory and it can be used for other object creations. So an object in the heap is said to be reachable if it is referenced by any local reference in a runtime stack. So a reachable object is alive and accessible by the live thread. So a object can be accessible by more than one thread, and any object that is not accessible by live thread, it is candidate for garbage collection. So that's what we discussed. So if you look at this picture here, this dark squares, I mean like these filled rectangles, these are the eligible objects. So these O13, see here, O13 and O16, these these objects can be garbage collected, whereas these reachable objects O4, O5, O6, O7, these objects are reachable objects. And if you look at here, we have a separate threads, and these threads, what it does, it will check whether these objects O1 to O16, any objects are reachable or not reachable. So if they are not reachable, then they are eligible for garbage collection. There are some other techniques to facilitate garbage collections. Objects that are created and accessed by local references in a method are eligible for garbage collection. So generally, if we have suppose display, okay, in a test class, if we have display, under the display, if we have some method variables like local variables, what we already discussed local variables, right? So local variables are specific to the method, not for the class. So any variables that are part of the method are first eligible for garbage collection, because their lifetime is only till the method is live. I mean, like, once the method execution completes, then those variables will not be used anywhere in the class. So first, local references in a method are eligible for garbage collection. And second point is, when a method returns a reference value and the object denoted by the value is not needed. Okay, not assigning this value to reference also facilitate garbage collection. So if any value or reference that method returns, and the object denoted by the value is not needed, if it is not needed, then that is also facilitates the garbage collection. If a reference is assigned a new value, the object that was previously denoted by the reference prior to the assignment can become eligible for garbage collection. Suppose, okay, if we have a b c, okay, and a equals to b, b equals to c, okay, then c equals to a. So I mean, like, any variable that is not associated, if a reference is set to a new value, okay, then that the object was previously denoted by the reference that can be eligible for garbage collection. And removing reachable references to a composite object can make constituent objects eligible for garbage collection. And this garbage collection can also maintained through programmatically. So we discussed that Java provides itself this garbage collection. So not only Java, I mean, like, we can write as a programmer, we can also use Java API to write this garbage collection. So although Java provides facilities to invoke garbage collection explicitly, there are guarantee that it will be run. The program can also request the garbage collections to be performed. So how we can, there is a method called GC under system class. Okay, this method is used to request garbage collection. And also we have run finalization method. This can be called to suggest any pending finalizers to be run that are eligible for garbage collection. Okay, and alternatively, not only system class, we have one more class called runtime class. It is also has this GC method and run finalization. So how do we get this runtime class? Is runtime object. We have runtime dot get runtime method to get the runtime object. Next, object finalization. Object finalization provides an object with a last resort to undertake any action before its storage is reclaimed. Suppose if a particular object is there, and we this garbage collector, what it does is, I mean, like, it wants to reclaim the memory. So if you want to do something with that object, then that can be done through this finalization. So the automatic garbage collector calls the finalize method an object which is eligible for garbage collection before actually destroying an object. So whenever garbage collector destroys this object, so during that process it will call the finalize method of object. So if you want to perform any specific operation when a particular object is to be destroyed, okay, so if you want to destroy any particular object, so before destroying this object, if you want to perform some actions, like, for example, connection. So if you want to establish a connection from a database, okay, connection is an object. So when garbage collector wants to reclaim the memory of this connection object, so before reclaiming we need to close the connection. So in the finalize method, we can write the connection dot close. So what it does, it will close the connection and then freeze the memory. So that kind of operations or steps we can write in the finalize method. So an implementation of the finalize method is called the finalizer. A subclass can override the finalizer from the object class in order to take more specific and appropriate action before an object of subclass is destroyed. Okay. Next concept is initializers. Initializers can be used to set initial values for the fields in the objects and classes. So, fields means, like, if we have one class called test and in the test class if we have variables a b c, so these are the fields. Okay, if we want to set some values, initial values when the object is created, so that is known as initializers. Okay, there are three different types of initializers. One is field initializer expressions, second static initializer blocks, third instance initializer blocks. We will discuss each and every initializer. Field expression initializers. Initialization of fields can be specified in the field declaration statement using initialization expressions. The value of the initializer expression must be assignment compatible to a declared field. Suppose here, if you look at here, constant integer minimum is equals to 12 and static double pension points equals to 10.5. So the first one is, this is a non-static initializer, whereas this is static initializer. So any value, so this 12 is in int value, right? So this expression, this is known as field expression initializer. Okay, the fields of an object are initialized with the values of initializer expressions when the object is created by using a new operator. So when you create a class for constant initializer, then these values will be assigned to these fields. This is known as field expression initializers. Okay, let me give an example on field expression initializers. Okay, here we have created one class called hotel. Okay, in this we have three fields: number of rooms, maximum number of guests, occupancy per room. And number of rooms is assigned with integer value 12, and maximum number of guests, here we have one method init max guests. Okay, and occupancy per room 2. So here public integer init max guess, system.out.println occupancy per room. So here we are printing something. So occupancy per room and number of rooms into occupancy per room we are returning for this particular method, and that is assigned to maximum number of guests. And here we have two methods, maximum number of guests and get occupancy. So when the object is created, see the order, how the order follows. So if you look at here, number of rooms first, right, 12, and then maximum number of guests. So maximum number of guests is equals to init max guess. So in the init, so um, compiler will go to this particular method, and it compiles this particular method and it executes. So um, so method flows into this so logic flows into this particular method. Here if you look at here, system out println occupancy per room. So by this time, so this is the second declaration, right? Here occupancy per room, it is not yet initialized. So what the value will get for this particular method occupancy per room, we will see. And so for this, what I did, a test order here, and hotel h equals to new hotel. So what we will do, we will create a, we have created only object here. So we will run as Java application. See here, occupancy per room 0, maximum number of guests 0. Why? See here, if we look at the order of these variables, number of rooms first, 12, maximum number of guests is a second variable, and in the second variable, what do we have? We have one method. So it will go into the method, and here occupancy per room. So by this time, this the third variable is not yet initialized. So if we don't initialize any particular variable, then value is 0. So primitive data type integer value default value is 0, and maximum number of guests is number of rooms, and means 12 into 0. So that's why maximum number of guests is 0. So next, then, so after assigning maximum number of guests 0 0, then occupancy per room 2 will be initialized. So what we will do, we will change the order here. Okay, so if we change the order of these variables, what will happen? So occupancy per room 2, and number of rooms 12 into 2, 24. Let's see, we'll run this application. Okay, run as Java application. See here, occupancy per room 2, and 24 because the second variable is initialized first, then the third variable initialized. So in this way, these order of these field expressions will be evaluated. Static initializers. Java allows static initializer blocks to be defined in a class. Although such blocks can include arbitrary code, they are primarily used for initializing the static fields. So these static fields will be initialized for initializing the static fields. The code in the static initializer block executed only once when the class is initialized. When the class is first loaded, first static fields, then instant fields, then static blocks are executed. Let me give an example on static initializers. So we are using the same hotel example here. Private static int number of rooms equals to 12. Private int occupancy room equals to 12, 2. So this is a static variable and this is instance variable. So here, if you look at here, this is the static initializer. Okay, static and open braces and system.println number of rooms. See here, only in the static initializer we can use the static variables. If we try to use occupancy room here, see here, we are not able to find this occupancy per room because that is an instance variable. So here, number of rooms. And so first a static variable will be initialized, then in instance variable, after that static variables. So if you look at here, if I run as Java application 24, so this, when the object is created, this will also be invoked, the static initializer, and that's why this system.println is executed and we got the result as 24. Okay, next, instance initializers. Just as static initializer blocks can be used to initialize static fields in a named class, Java provides the ability to find initialize fields during the object creation using instance initializer blocks. In this respect, such blocks serve the same purpose as constructor during the object creation. The syntax of instance initializer block is the same as the local block. So how we create a local methods in the same way, so and even constructors. So we will discuss about the constructors in further sessions, in future sessions. The code in the local block is executed every time when the instance of the class is created. So in the earlier example what we did in the static initializer, it is used static fields, whereas in instance initializers we can use the instance variables and that can be initialized. Okay. If you have any queries on today's session, please mail us at info@bicourses.com. We are happy to answer our queries and questions. Thank you so much.